Hey everyone, welcome back to Smart Architecture Programming, your go-to place for coding knowledge made simple. In this video, we're diving into a fundamental concept of Java, exception handling. This lesson is part of our companion series to the Introduction to Java book that we published, so if you're reading along, you're in the right place. Today we'll explore what exceptions are, the difference between checked and unchecked exceptions, why exception handling matters, and common scenarios where you actually need to implement exception handling. So this is an important topic for you to implement, because exceptions are a daily part of any coding that you do, whether in Java or any other programming language. So dealing with exceptions is essential for you to have a clean, workable, robust code base that can actually be deployed in real world projects. If you do not have exception handling, you probably wouldn't be able to deploy your code on the public facing side anywhere. So without further ado, let's first understand what exceptions are in Java. So in Java, an exception is an event that disrupts the normal flow of the program's instructions. Think of it as an error that Java throws at you when something unexpected happens during execution. Simply speaking, any bug, any problem that props up in your code base causes it to stop running, or for Java or the JVM to throw an error. That is an exception. That exception is stopping your code from actually working. Basically, let's say that you're trying to divide a number by 0. That's not allowed in maths, and Java agrees. It throws an arithmetic exception error, a type of a runtime error. I'm not going to focus on the types of errors that might appear. There are runtime errors and there are other types of errors. What you need to understand in this particular video are errors at all. But keep in mind, not all exceptions are created equal. Java categorizes them into two types, checked and unchecked exceptions, and we'll be focusing on developing an understanding around those as well. Because again, exceptions are fairly easy. Anything that stops the normal flow of your code, stops JVM from compiling your code and running it, that's an exception. So what are checked versus unchecked exceptions in programming or in Java? Checked exceptions are checked at compile time. That means that the compiler forces you to handle them using try-catch blocks or by declaring them with throws. Examples include basically IO exception errors, SQL exception errors, and file not found exception errors. On the other hand, unchecked exceptions occur at runtime. You don't need to catch them explicitly, though you often should. Example includes null pointer exception, arithmetic exception, and array index out of bound exception. So basically, you need to understand two things with checked and unchecked exceptions. Checked, and this is something that if you don't understand that much, it's not that big of an issue, but just try to develop an understanding around it. Basically, checked exceptions are essential to those that happen at compile time. Basically, your compiler forces you to handle them with try-catch blocks or by declaring them with throws, because otherwise they would not stop the normal flow of the code. Unchecked exceptions occur at runtime. You don't need to catch them explicitly, though you often should. Again, basically, you need to understand there are two types of these exception errors. And in more particular, you need to understand specific exception errors and understand what they mean, because that is how you'll do the debugging of your code. So with that understanding developed, we need to focus on why there's a need for exception handling in our code bases. So basically, what you need to understand with exception handling is that if you don't handle exceptions, your program can crash unexpectedly, and users hate that, and they probably leave your program to find some that doesn't have those issues. With exception handling, you can catch, throw errors, log them, inform the user politely, or even recover from them. Basically, it makes your code more robust, user-friendly, and maintainable. So Java uses try, catch, finally, and throw to help you manage exceptions gracefully. You learn how to use each of these in practical scenarios as you advance further. So here, with that some understanding of why we need to exception handling, let's throw some common situations that require exception handling at you. So some everyday situations in Java development where exception handling is essential are as follows. Number one, file handling. When reading from or writing from a file, reading or writing to a file rather, IO exception and file not found exceptions are very, very common. File not exception error is as it's clearly describing that the file you're trying to write or read from was not where you presumed it to be. Number two is user input. Taking input from user often causes errors. You need to handle multiple ways a user might input information. Whether it's if you're asking them for a digit, they might enter strings. If you're asking them for a string, they might enter digits. If you want a digit for a certain range, they might not enter them within that certain range. So all of that needs to be understood and handled. Usually there's an input mismatch exception if they enter something that is completely unexpected. Like I mentioned, there's so much ways a user can incorrectly enter information. You need to handle as many situations of the input mismatch as you can. So number 3 comes collections and arrays. Accessing an array index that doesn't exist in an array or a list, that's array index out of bound exception or index out of bound exception. Basically, when you have a 5 member array, you're trying to access 6 or 7 seventh element within that array that doesn't exist in that array. That's out of bound errors. Then we have null references. You're trying to access a method on a null object. Basically, you're trying to access a method a method on an object that doesn't exist, basically. So you get null pointer exception. And then you have database connection errors. When you're working with databases, that becomes extremely annoying, even for semi-advanced programmers, because working with databases is oftentimes difficult. So SQL exception errors is a regular visitor if you're working with databases. The key is to anticipate where things can go wrong. Basically, you need to anticipate where things could, like with the user input, you need to anticipate what sort of inputs the user could put in that are wrong, and use exception handling to protect your code and improve your user experience. So without I think clarity, understanding handling exceptions is a critical part of becoming a skilled Java developer. It's not just about fixing bugs, it's about writing software that behaves predictably even when things go wrong. If this video helped clarify things for you, don't forget to like, subscribe, and drop your questions in the comments below. And remember, this is part of our companion series to the Introduction to Java book, so grab your copy from Smart Architecture Programming if you haven't already. See you in the next video, where we break down try, catch, finally, and how to write custom exceptions themselves. And this chapter is all about exception handling and how that can help you improve your code base robustness and pushing forward. With that, I'm signing off. Code smart and live smarter.